Right now, as you watch this, you are doing almost nothing. Maybe you are sitting. Maybe you are lying down. Maybe you have not moved in the last 20 minutes. From the outside, it looks like nothing much is happening. From the inside, the situation is completely different. Right now, while you sit still and watch a screen, your heart is beating somewhere between 60 and 100 times per minute. Your lungs are pulling air in and pushing it out, adjusting the rate automatically based on chemical signals your brain is constantly monitoring. Your immune system is identifying and neutralizing threats you will never know about. Your hormones are managing your hunger, your alertness, your body temperature, and your mood, all at the same time, all without asking your permission or your attention. You think you are resting. Your body has not rested once in your entire life. The human body has one job that it never stops doing. And the remarkable thing is not just that it does this job continuously. The remarkable thing is that it does it invisibly, automatically, and in most cases without ever making you aware of the extraordinary complexity of what is happening inside you every second of every day. Subscribe to Freud Mind, and let us take a proper look at what is actually going on in there. It starts before you are born. Approximately 3 weeks after conception, your heart begins to beat. A tiny cluster of cells, destined to become the most reliably working muscle in the human body, begins its rhythm. It will not stop for the rest of your life. The human heart is, at its most basic, a pump. But describing it as just a pump is like describing a symphony orchestra as just a collection of instruments. The heart is a dynamic, constantly adjusting, self-regulating system that manages one of the most complex delivery networks ever to exist, the circulatory system, with a precision that no machine has yet been able to replicate in a form that runs continuously for 80 or 90 years without significant maintenance. In a typical day, your heart beats around 100,000 times. In a year, that is approximately 35 million beats. Over a lifetime of 75 years, it beats something in the range of 2.5 billion times, without a single break, without a single vacation, without ever being switched off for maintenance. Each beat sends blood surging through about 100,000 kilometers of blood vessels, an extraordinary number that includes the largest arteries and the tiniest capillaries, some so narrow that red blood cells have to pass through them single file. The heart adjusts itself constantly based on what the body needs. When you sleep, your heart rate slows, dropping to as low as 40 to 50 beats per minute in some people during deep sleep, because the body's overall demand for oxygen and nutrients decreases. When you wake up, the heart rate begins rising before you even get out of bed, responding to hormonal signals that the brain is already sending in preparation for activity. When you exercise, the heart can more than double its output, increasing both the rate and the force of each beat to meet the muscle's dramatically higher demand for oxygen. When you experience stress or fear, the heart responds within seconds, sometimes within fractions of a second, to the adrenaline that the stress response releases, speeding up and strengthening its contractions to prepare the body for action. This adjustability is one of the heart's most remarkable features. It is not running at a constant fixed rate. It is continuously reading the body's needs and responding to them in real time, managed by a combination of its own electrical system, the nervous system, and the hormonal environment. Two distinct systems in the heart itself, the sympathetic and parasympathetic nervous systems, operate in constant dynamic balance, one accelerating the heart and one slowing it, producing the precisely calibrated rate that each moment requires. What happens if it stops? Even brief interruptions to the heart's rhythm produce immediate effects. Dizziness, loss of consciousness within seconds, serious consequences within minutes if the rhythm is not restored. The heart's continuous operation is not optional for the rest of the body's function. Everything else depends on it. You breathe approximately 15 to 20 times per minute when resting. That is around 20,000 times per day, roughly 7 million times per year, and somewhere in the region of 500 million times over a lifetime. You do not think about almost any of these breaths. They simply happen. The control of breathing is one of the most elegant automatic systems in the body. Deep in the brainstem, the most ancient part of the brain, the part that handles fundamental survival functions, there is a cluster of neurons that generates a continuous rhythm of breathing signals. This respiratory center monitors the levels of carbon dioxide and oxygen in your blood continuously and adjusts the depth and rate of breathing accordingly. You do not consciously manage this process any more than you consciously manage your heartbeat. It runs on its own, responding to conditions your conscious mind is not even aware of. When you exercise, your muscles produce carbon dioxide much faster than when you are resting. The blood carbon dioxide level rises. The respiratory center detects this change and immediately increases your breathing rate, not because you decide to breathe faster, but because the chemical signal has been received and responded to automatically. The same system operates in reverse. When carbon dioxide levels are low, as they are if you breathe very rapidly for a period, the breathing rate is reduced until balance is restored. During sleep, breathing continues automatically, managed by the same brainstem systems. In most people, it slows somewhat during sleep as the body's metabolic rate decreases and the demand for oxygen is lower. During dreaming, however, breathing often becomes more irregular and variable, reflecting the increased brain activity of the dreaming state. In people with sleep apnea, breathing actually stops repeatedly during sleep, triggering partial awakenings as the brain detects the disruption in oxygen levels and forces the system to restart. This is why untreated sleep apnea is associated with such significant health effects. The body is being repeatedly jolted out of restorative sleep by a breathing system that is struggling to maintain its automatic function. One of the interesting things about breathing is that it sits at a unique intersection in the body. It is automatic, but it can also be consciously controlled. You can hold your breath, breathe faster deliberately, take a slow, deep breath. This voluntary control is one of the reasons that breathing exercises work in managing stress. By deliberately slowing and deepening the breath, you can activate the parasympathetic nervous system and produce genuine physiological calming effects. You are using the voluntary pathway to influence the automatic one. The interaction between the two is one of the reasons breathing has been a focus of meditation and relaxation practices across cultures for thousands of years. The brain is not resting when you sleep. If anything, certain parts of it are more active during sleep than during waking hours, just differently active, doing work that waking life does not allow time or conditions for. Sleep is not a single uniform state. It is a structured cycle of different stages that repeat several times through the night, each serving different functions. The early part of each cycle involves lighter stages that transition into deep, slow-wave sleep, the stage during which the most restorative physical repair happens, and during which growth hormone is released in its largest daily pulse. Later in the sleep cycle, the brain transitions into REM sleep, rapid eye movement sleep, during which the most vivid dreaming occurs and during which very different biological work is being done. During slow-wave sleep, one of the most important processes in the entire body is operating. The glymphatic system, a waste clearance system that is specific to the brain, becomes dramatically more active. During waking hours, the brain's cellular activity produces metabolic waste products that accumulate in the fluid surrounding brain cells. During deep sleep, the flow of cerebrospinal fluid through the brain increases dramatically, effectively flushing these waste products out. Among the substances cleared this way are proteins associated with neurodegenerative diseases, including amyloid beta, whose accumulation in the brain is a feature of Alzheimer's disease. The nightly cleaning of the brain is not a minor maintenance task. It appears to be a fundamental process for long-term brain health. During REM sleep, the brain is highly active, more metabolically active, in fact, than during quiet waking. Memory consolidation is happening in earnest, Experiences from the day are being processed, sorted, and integrated into long-term memory. The connections between neurons are being strengthened for things learned and practiced during the day, and weakened for things that are no longer needed. Emotional experiences are being processed in a different neurological context, separated from the immediate stress hormones that accompanied them during waking, which appears to allow the emotional charge of difficult experiences to be somewhat reduced, a process sometimes described as overnight emotional processing. Dreams appear to arise from this active brain state, though their precise function is still debated. What is clear is that the sleeping brain is not simply waiting for morning. It is reorganizing, cleaning, consolidating, and preparing, doing work that contributes directly to the quality of thinking, memory, and emotional regulation that the next day will depend on. This next one is happening inside you right now, and you are not going to notice any of it. Your immune system is an extraordinarily complex, distributed network of cells, proteins, and organs that operates continuously throughout your entire body, performing surveillance and defense functions that together constitute one of the most sophisticated security systems in the biological world. And it almost never needs your conscious attention. The immune system runs in what might be thought of as two layers. The first, the innate immune system, is a rapid response system that reacts immediately to anything it recognizes as foreign or dangerous. It does not need to learn. It is pre-programmed to respond to broad categories of threat. When bacteria enter a cut in your skin, the innate immune system is responding within minutes. White blood cells flooding the area, inflammation signals calling for backup, physical barriers being reinforced. Most of the time, this system stops threats before you are aware of them. The slight redness around a small cut is the visible tip of an invisible defense response that is actually quite substantial. The second layer, the adaptive immune system, is slower but vastly more specific and more powerful. It learns. When it encounters a pathogen, it creates specific antibodies tailored to that exact threat and maintains a memory of that pathogen that allows faster, stronger responses to future encounters. This is the system that vaccination works with, presenting the immune system with enough information about a threat that it can build specific defenses without requiring the full disease. The adaptive immune system's memory is extraordinary. Some immune memories persist for decades or even a lifetime. Every day, without your awareness, your immune system is also surveilling for abnormal cells, cells whose internal control systems have malfunctioned in ways that could lead to uncontrolled growth. Most of the time, these cells are identified and eliminated before they can develop further. The immune system's role in cancer prevention, continuously identifying and eliminating cells that have gone wrong, is one of the more sobering illustrations of how much is happening inside the body at any moment without rising to conscious notice. When the immune system is occupied with a major challenge, a significant infection, for example, you experience this as feeling ill, the fever, the fatigue, the reduced appetite. These symptoms are not the illness itself. They are largely the immune system's strategies for dealing with the threat. Fever makes the body less hospitable to many pathogens. Fatigue redirects energy from active behavior toward immune function. The reduction in appetite in sick animals is thought to divert energy away from digestion and toward defense. The miserable feeling of being sick is, in a sense, your immune system asking you to stay still and let it work. Blood is a transport medium carrying multiple distinct types of cargo simultaneously, managed by different cell types, to destinations distributed across every tissue in the body. Red blood cells, the most numerous type, carry oxygen from the lungs to every tissue and carry carbon dioxide back for exhalation. White blood cells are the immune system's mobile forces, patrolling for threats. Platelets are standing by for damage control, ready to initiate clotting the moment a blood vessel is breached. Plasma, the liquid portion of blood, carries nutrients from the digestive system, hormones from the glands that produce them, proteins for a dozen different functions, and waste products on their way to the kidneys for filtration. The circulatory system also plays a major role in temperature regulation. When you are too hot, blood vessels near the skin surface dilate, bringing warm blood closer to the surface, where heat can be lost to the surrounding air, which is why you look flushed when you are overheated. When you are cold, those vessels constrict, keeping warm blood away from the surface and closer to the vital organs at the body's core, which is why extremities like fingers and toes are the first things to feel cold. Blood clotting is one of the most precisely calibrated cascade processes in biology. When a blood vessel is damaged, a series of chemical signals triggers a rapid sequence of reactions that culminates in the formation of a clot, a mesh of fibrin proteins that traps blood cells and seals the breach. This process needs to be fast enough to stop bleeding before dangerous amounts of blood are lost, but not so aggressive that it creates clots in undamaged vessels, which is itself life-threatening. The regulation of this balance, always ready but never triggering without cause, involves dozens of separate factors that must be present in the right proportions. Your body is also in a state of continuous construction and reconstruction. Your skin replaces itself approximately every 2 to 4 weeks. The outermost layer of skin cells is constantly being shed and replaced by new cells produced in the deeper layers. The skin you are wearing right now is not the same skin you had a month ago. Your red blood cells have a lifespan of approximately 120 days, after which they are broken down and their components recycled, meaning the bone marrow is continuously producing new red blood cells at a rate of approximately 2 million per second, every second, throughout your life. Bone is not the inert, fixed structure it appears to be. It is living tissue that is continuously being broken down and rebuilt. Old bone is dissolved by cells called osteoclasts, and new bone is laid down by cells called osteoblasts. This remodeling process serves several purposes. It allows bone to respond to mechanical stress, strengthening areas that are regularly loaded. It allows calcium to be released into the blood when needed. And it repairs tiny structural damage that accumulates from daily mechanical stress before it becomes significant. Over roughly 10 years, most of the mineral content of the adult skeleton has been replaced through this continuous remodeling process. Muscles recover from the tiny structural damage of use during sleep and rest periods. The growth and strengthening of muscle in response to exercise is not happening during the exercise itself. It is happening in the hours and days afterward, as the body repairs the microscopic damage that exercise causes and builds the tissue slightly stronger than it was before. This is why rest is not the absence of progress in physical training. It is where the progress actually happens. Running all of this, coordinating the heart, the lungs, the immune system, the digestive system, the temperature regulation, the sleep cycle, the stress response, the growth and repair, is the hormonal system. An invisible chemical messaging network that operates continuously, sending signals through the bloodstream that regulate virtually every aspect of physiology. Hormones are molecules produced by specialized glands that travel through the blood to target cells, where they produce specific effects. The range of functions managed by hormones is extraordinary. Cortisol, produced by the adrenal glands, rises in the morning to help the body transition from sleep to waking alertness, peaks in response to stress, and declines through the evening. Melatonin, produced by the pineal gland, rises in the evening in response to darkness and signals the brain that it is time to prepare for sleep. Insulin, produced by the pancreas, manages the uptake of glucose from the blood into cells. Its release is triggered by eating, and its effects are immediately felt by almost every tissue in the body. Growth hormone, released primarily during deep sleep, drives the repair and rebuilding of tissues throughout the body. The hormonal system does not operate by simple on-off switches. It operates through dynamic, constantly adjusted feedback loops. When a hormone rises above a certain level, signals are sent to reduce its production. When it falls below a threshold, production is stimulated. The result is a constantly moving equilibrium, not a fixed state, but a continuously managed balance across dozens of interacting systems simultaneously. When this balance is disrupted by chronic stress, poor sleep, poor nutrition, or illness, the effects are felt across multiple systems simultaneously, which is why the symptoms of hormonal disruption tend to be diffuse and complex. Fatigue, mood changes, poor sleep, weight changes, reduced immunity. These are all potential consequences of hormonal balance being pushed outside its optimal range, because hormones are coordinating so many different functions at once. While you sleep, your body shifts into what might be called maintenance mode, not stopping, not resting in any meaningful sense, but reorganizing its priorities toward repair and consolidation rather than activity and response. Growth hormone surges during the early hours of sleep, driving the repair of muscle tissue, the maintenance of bone density, and a range of cellular renewal processes. The brain's glymphatic cleaning system runs its overnight cycle. Memory consolidation moves through its stages. The immune system, freed from some of the competing demands of active waking life, takes the opportunity to do deeper repair work and to mount more vigorous responses to infections that have been slowly accumulating. The body's temperature drops slightly during sleep, a deliberate adjustment that supports the restorative processes happening in deep sleep stages. Core temperature begins rising in the early morning hours, in anticipation of waking, before any alarm goes off or any conscious decision to wake has been made. The body is preparing itself for activity before the mind has been consulted about the day's schedule. This is why disrupted sleep has such wide-ranging consequences. When sleep is shortened, fragmented, or chronically poor in quality, the repair and consolidation processes that depend on it are interrupted or compressed. The brain's waste clearance is incomplete. Memory consolidation is impaired. Tissue repair is reduced. Hormonal rhythms are disrupted. The effects show up in cognitive performance, in mood, in immune function, in physical recovery, in long-term health risk, because sleep is not one thing. It is the condition under which dozens of critical biological processes do their most important work. We tend to think of staying alive as something passive, as the default state that continues unless something actively goes wrong. The reality is almost the opposite. Staying alive is the most active, complex, resource-intensive, continuously running project your body is ever involved in. Every second of your existence, billions of processes are operating simultaneously. The heart pumping, the lungs exchanging gases, the immune system surveilling and responding, the blood delivering and collecting, the hormones coordinating, the brain organizing, the tissues repairing and renewing. None of this requires your attention. None of it waits for your permission. None of it pauses while you sleep or rest or sit still and watch a video. The body you're living in right now is doing something genuinely extraordinary. And the most extraordinary part is that it has been doing it your entire life without ever once asking you to notice. It has one job. It never takes a break from it. And it is working right now, as you read this, with a reliability and a complexity that no machine ever built by human hands has come close to matching. Like and subscribe to Freud Mind. There is a lot more where this came from.